Okay, so it sounds like you're bullish on emerging technology fields really coming back with a vengeance in 2023. On that note, I read an interesting article the other day talking about how Bosch is using IBM quantum computers to make EV materials. First question, how does that work? And second follow up, sounds like a pretty big deal, right?
Yeah, it's really cool stuff. So what's going on over there is obviously the supply of materials, specifically rare earth minerals, needed to make electric vehicles, lithium ion batteries specifically, so batteries for energy storage systems as well, is obviously limited. I mean, there's not an infinite amount of lithium on this planet, not an infinite amount of cobalt, not an infinite amount of magnesium and all that stuff. So it's limited, and where it comes from is also very unique. So we have to go through some geopolitical challenges there. So the supply of minerals for batteries is a huge issue right now. And there are a lot of companies trying to fix that issue. Now, what Bosch is doing, which is really interesting, is they're trying to leverage quantum computers to create simulations that allow us to recreate the composition of rare earth minerals and actually manufacture them in labs from things that are not rare earth minerals, from more abundant materials and more locally sourced materials. Now, that would be amazing. It's a long shot, and we're very early in the process, but that would be absolutely amazing if, as opposed to going to the Congo to get cobalt, or going to China to get lithium, we could just take sand from a beach in North Carolina and somehow make that an electric vehicle battery by recreating the composition of lithium, recreating the chemistry of lithium. Like, that would be a really novel, amazing, world-changing technological breakthrough, and it's empowered by quantum computers. Now, the way it's empowered by quantum computers is because it's all simulations, right? When you have a quantum computer, it can run infinitely more simulations, infinitely faster, infinitely more accurate simulations than a classical computer. So if you were running simulations like this on a classical computer, you're basically being asked to build a home with a shovel, and that's all. Now, with the quantum computer, you're being asked to build a home with an entire construction crew. So that's basically what's going on here, and that's why they're using quantum computers to do that, and why it is the only viable path forward for accomplishing something so enormous. But the fact that they're doing that, and other companies are using quantum computers, other automakers are actually using quantum computers to figure out how to better engineer a longer lasting battery, the 1,000-mile battery, the long sought after 1,000-mile battery. It all comes back to this idea that quantum computers are finally at a point where they can be useful in the real world. It's not just a theory. It's not just something Einstein got stumped by 100 years ago. This is a real thing now with real applications and real value adds, and companies are just now starting to figure out how to extract that value. So it's the first inning of the ball game for quantum computing, and I think there is a long and promising ball game ahead for investors in quantum computing stocks. So it's not a quick hit. It's not an instant winner. But if you have time on your side and you're willing to wait and let it marinate, now is as good a time as ever to buy quantum computing stocks and see where they go in the next 3, 4, 5 years. I think the gains could be pretty tremendous as quantum computing goes from this thing that sounds really cool that some companies are using to a ubiquitous must-have technological add-on for all enterprises. That's a transition that will cause these stocks to soar if it does happen. So I think now is a pretty good time to roll on in to those quantum computing stocks.
It sounds like a complete coalescence of all the things that we talk about, that you love to talk about, all the big tech, automation, EVs, AI, simulation, quantum computing.
Right. I wouldn't say it's a coalescence so much as it's a catalyst for all of them. What do all of these technologies have in common? They're built on computers, right? Automation software, automation hardware is all built on a computing program. DNA sequencing, all that stuff, synthetic biology is built on computing programs. Artificial intelligence, voice AI, all that stuff built on computer programs. Even when you're launching rockets into space and communicating with them, that's built on computer programs. So when you fundamentally change the computer program into something infinitely better, faster, stronger, more powerful, you accelerate all these technologies by tenfold. So by investing in quantum computing, you're not just investing in something that all these technologies are going to need, but you're investing in something that if it works is going to take these technologies to a whole new playing field, every single one of them. So it's not the coalescence so much as it's the foundation, the fundamental change of the foundation upon which these technologies are built. So that's the kind of common thread there.
Thanks for watching HGI Clips. For the full episode, head on over to our sister channel at Hypergrowth Investing by clicking the link in the description or listen to the podcast on any of your favorite streaming platforms. We make new episodes every Wednesday, so make sure to check it out and subscribe to never miss any of Luke's Hypergrowth insights.